Section 11.1 talks about empirical probabilities. So, Chapter 11 in general is a probability chapter. We're going to go through each of these sections and see if we can't figure out if any of this stuff makes sense. Okay, so the first thing we have here is something called an experiment. It says an experiment is a controlled operation that yields a set of results. The outcomes are the possible results of an experiment are called the outcomes. And the event is a subcollection of the outcomes of an experiment. So let's think of an example. For our experiment, we could say we're going to flip a coin. Okay. The outcomes are we can end up with heads or we can end up with tails. The event is going to be the specific. Say we want to figure out what's the event of getting a heads. That would mean we flip it once, we land on heads, that's that particular event. We could do it with tails, but the important thing is that there are two outcomes, right? The event would be one of those, okay? So if you look here in the middle, it kind of gives us an example, okay? When we roll a die, so guys, if you think about a die, in case you're not certain what they look like, it's going to look something like this. Right, boom, boom, boom. And so let's see. So maybe we have 1, 2, 3, 4 here, 2, 3, and maybe 1, 2, 3, 4, 5, something like that, right? That's what our die is going to look like. All right. So let's see. It says rolling a number greater than 2 can be satisfied by the outcomes 3, 4, 5, or 6. Okay, the event of rolling a 5 can only be satisfied by only one outcome, the 5 itself. And the event of rolling an even number can be satisfied by 3 outcomes, those outcomes being landing on either a 2, 4, or 6. Okay, so it says probability is classified as either empirical, which is what we call experimental, or theoretical, which is our mathematical probability. It says empirical probability is the relative frequency of occurrence of an event and is determined by actual observations of an experiment. Determining the chance of something happening in the future by observing past results is called empirical probability, okay? Theoretical probability is determined through a study of possible outcomes that can occur for each of the given experiment. It says right here, we'll indicate the probability of an event. And the way we read this right here, guys, P of E, okay? Let's take a look. It says the probability of an event, P of E, can be determined by the following. The number of times event E has occurred divided by the total number of times the experiment has been performed. So our first problem here says, in 100 tosses of a fair coin, 44 landed heads up. Determine the probability of the coin landing heads up. Okay, so we're going to say the probability of getting a heads. Okay, well, how many times did we flip that coin? We flipped it 100 times. Out of those 100 times, how many times did it land on heads? 44. So our probability would be 44 out of 100, okay, because of this particular experiment. Okay, this is what we call empirical probability. All right. The next one says a pharmaceutical company is testing a drug that is supposed to help reduce high blood pressure. Let's see. It says the drug is given to 500 individuals with the following outcomes. Out of those 500 people, 379 had a reduced blood pressure, which is good. That's what we want. 62 had no change. And 59 actually had the opposite effect. They had an increase in blood pressure. Okay, so the first question says, if a drug is given to an individual, determine the empirical probability that the person's blood pressure is A, reduced. Okay, so the probability that it is reduced out of the 500 patients, 379 had a reduced blood pressure. Okay. Part B, what is the probability that their blood pressure is unchanged? Out of the 500 individuals, 62 of them were unchanged. And the probability that the blood pressure was increased, out of the 500 individuals, 59 had an increase in blood pressure, okay? All right. So the next thing here says the definition of the law of large numbers. It says the law of large numbers states that the probability statements apply in practice to a large number of trials, not necessarily to a single trial. It is the relative frequency over the long run that is accurately predictable, not in individual events or precise totals, okay? So, a perfect example of the law of large numbers. If I go down to Stripes to go get my Q taco in the morning, and once I get my Q taco, I have exactly $2 in change, and I ask the person behind the counter, can I get a weekly grand lottery ticket? And suppose this is the first time I'm buying a weekly grand lottery ticket, and I go home and I scratch it, and behold, I win. So that what would be the probability of me winning? It would be 100%, because that's the first ticket I ever bought, and I won. But we know that that's probably not the likelihood, right? The likelihood is we can go buy 1,000 tickets, and maybe out of those 1,000, we win one, right? So the law of large numbers says that the probability is going to be more accurate when we do this for a large number of trials, okay? So if I were to go buy a lottery ticket and I don't win, we wouldn't necessarily say the probability of winning is 0, because then people wouldn't buy lottery tickets, right? Again, this occurs over the long run, okay? Equally likely outcomes. If each outcome of an experiment has the same chance of occurring as any other outcome, we say they are equally likely, okay? So equally likely outcomes, guys, like we did earlier, if we're going to roll a dice, right, something like this again. Okay, remember, you can either land on a 1, 2, 3, 4, 5, or 6. These are all equally likely, right? So it says, since the chance of flipping a head is the same as flipping a tail, equal likely outcomes. If we draw a single card from a standard deck of cards, there are 52 cards that can be drawn. The chance of drawing any one is the same for all 52 cards. So the results of this experiment are called equally likely outcomes. All right, so let's take a look here. It says, a fair dial is rolled. Determine the probability of rolling a 2, an even number, a number greater than 3, a 7, a number less than 7. Okay, so we said earlier that when we roll a die, guys, dies have 6 sides. So we can either get a 1, 2, 3, 4, 5, or 6. So the number of outcomes is going to be equal to 6. Okay. So now, part A. What's the probability that we're going to get at 2? Well, out of the 6 numbers that we have right here, how many of those numbers happen to be a 2? Just one of them. So my probability would be 1 out of 6. Okay. Part B. What's the probability that we're going to get an even number? Okay. Well, out of the 6 numbers that we have here, 3 of them happen to be even. I'm going to go ahead and reduce my fraction to 1/2. Okay. Let's see. Part C. A number that is bigger than 3. Okay. Well, out of the 6 numbers that I have here, those 3 numbers are greater than 3, right? So again, if I reduce that, that's going to give me 1/2. Part D is in dog. What's the probability that I'm going to get a 7? Out of the 6 numbers that I have here, how many of them are 7? None of them. So 0 divided by 6 is 0. And then part E, oops, not F, but a P. What's the probability going to get a number that is less than 7? Well, out of the 6 numbers that we have here, all 6 of them are less than 7, so the probability is going to be equal to 1. Okay. All right, so before I go on, I want you to look at part D and part E. Okay. Let's see. Part E says, what's the probability that, I'm sorry, let's do part D first. Part D, what's the probability we're going to get a 7? It's impossible to get a 7. So if it's impossible, the probability is going to be 0. Okay. What's the probability that I'm going to get a number less than 7? I'm guaranteed to get a number less than 7, so the probability is going to be 1. Okay. If the probability cannot occur, it's 0. If the probability has to occur, it's going to be equal to 1. All right. And before I do this next problem, I want you to look right here. The probability that an event cannot occur is 0. The probability that it must occur is 1. And every probability is going to be a number between 0 and 1 inclusive. That means we're including those two numbers. And then the part 4 says the sum of all possible, the sum of probabilities of all possible outcomes is equal to 1. Okay. All right. Let's take a look at this boat rental problem and see if we can't figure it out. The last 30 boat rentals at Green Lakes Boat Rentals were 14 sunfish, 10 kayaks, and 6 rowboats. Use the information to determine the empirical probability that the next boat is a sunfish, kayak, and rowboat. Okay, so again, the number of outcomes that we have here is equal to 30 because it's talking about the last 30. So part A, what's the probability that we're going to get a sunfish? Well, out of the 30 boats that we rented, 14 of them were sunfish. Guys, I'm just going to reduce my fraction by dividing them both by 2. 7 over 15. Okay. What's the probability that we're going to get a kayak? Out of the 30 last boat rentals, 10 of them were kayaks. I'm going to reduce that to 1/3. Okay. And part C, what's the probability we're going to get a rowboat? Out of the 30 rentals, we had 6 of them happen to be rowboats. Again, we can reduce that to 1/5. Okay. All right. So let me keep scrolling down here. And it says the sum of probabilities. So the probability that an event occurs plus the probability event that it does not occur is going to be equal to 1. Another way we can think about that is the probability that it's not going to occur is going to be equal to 1 minus the probability that it will occur. Okay? I'm going to explain that in the next problem here. Excuse me. Okay, so it says a standard deck of 52 playing cards is shown in the picture. So guys, give me 1 second. Here's our picture. These are my deck of cards. So one thing I want you to notice we have 4 suits. We have the clubs, we have the spades, we have the hearts, we have the diamonds, okay? Let's see. These are our face cards, right? So Jack, Queen, King, Jack, Queen, King, Jack, Queen, King, Jack, Queen, King, okay? We have 4 aces, we have 4 twos, we have 4 threes, so on and so forth, okay? Let's see, we have 52 cards. So just to kind of do a little math before I even do anything else, if we have, let's see, 52 cards, and there are 4 different suits, we're going to figure out how many are in each suit. There are 13 in each suit, okay? All right, so let me come back to our notes. Let's see, we'll go back and forth between this and this just so we get an idea, okay? All right, so what do we got here? It says the deck consists of 4 suits, hearts, clubs, diamonds and spades. Each suit has 13 cards. We just verified that. The cards are numbered the ace, which is 1 through 10, and we have 3 picture cards, right? Or the face cards. The jack, queen, the king, and the king. Hearts and diamonds are red. Clubs and spades are black. There's 12 picture cards. We looked at that earlier. 4 jacks, 4 queens, 4 kings. Okay, so now let's do part A. What's the probability that we're going to get an 8? Well, we know that we have a total of 52 cards, right? If I come back and look at my picture, how many 8s do we have? We have a total of 4 8s, right? So it's going to be 4 over 52, which we can reduce to 1 over 13. Okay. So what's the probability that we have not an 8? Okay. So a couple of ways we can think about doing this. If we know, coming back to my picture, if 4 of them were 8, how many were not 8, right? Well, we know we have a total of 52. So if I take 52 and I subtract those 4, we should be left with 48 over 52. Okay. Guys, if we reduce this, this is going to give me 12 over 13. Okay. Now, before I go on, I want you to look at these two numbers here. Okay. So look what it says here. It says the probability that something is not going to happen is going to be equal to 1 minus the probability that it does. So if I look at, say, this one here, out of the 13 cards, one of them would be an 8, right? What I mean by that is when I look at my picture, I'm just going to look at one of the rows. So say I'm looking at this row right here in the middle, okay, the top row, I'm sorry. So out of those 13 cards, if one of them is an 8, how many are not an 8? Well, the other 12, right? And that's sort of the easy way you can figure this out. I mean, we did it essentially here, but then we still had to reduce our fraction, right? Okay, let's do part C. Excuse me. What's the probability that we're going to get a club? Okay, well, we know we got a total of 52 cards. Okay, oops, sorry. 52 cards. Let's see, here we go. So out of those 52, how many are clubs? 13 of them, right? Okay, so I'm going to write right here, 13. Guys, I'm going to go ahead and divide them both by 13. That's going to give me 1 over 4. What I want you to think about is, look at my deck of cards again. There are 4 different suits. So the clubs is one of those 4 suits, right? Okay. Part D. What's the probability we're going to get a jack or a queen or a king? What's the probability that we're going to get a picture card? Okay. So I'm going to come back again to my picture. All right, and again, I want you to notice here, okay, so we know we have a total of 52 cards. Let's see how many of them are picture cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So 12 of them are picture cards, okay? Let's go ahead and reduce our fraction. So 52, can we divide it by 12? I don't think we can. No. Oops, clear. 52, can we divide it by 6? No. 52, can we divide it by 4? Yes, 13. Okay, good, perfect. So if we divide them both by 4, that's going to give me 13, and if I divide that by 4, that's going to give me 3. Okay. All right, part E. What's the probability we're going to get what it says here? It says a heart and a spade. Okay, so let me put it like this. Heart and spade. Okay, I'm going to come back and look at my picture. Are any of these cards both a heart and a spade? There aren't, right? There might be a 10 of hearts, but there's no heart spade card, right? So 0. Okay. And then part F, what's the probability that we're going to get a card greater than 5 and less than 9? So greater than 5 and less than 9, okay? Greater than 5 and less than 9, okay? So I'm going to come back here. Greater than 5 would be 6, 7, 8. Less than 9, I would just have to stop right there. So look, we can do it with just one of the rows. 3 out of the 13, right? There's 13 in any one of those rows, so 3 out of the 13. And let's go here. 3 out of the 13. Okay. All right. let's take a look at the next question. Multiple choice test has 5 possible choices for each question. If you randomly select one of the choices, what's the probability that you select the correct answer for one particular question? Okay, so we're going to have 5 choices. So look, let's go like this. 1, 2, 3, 4, and let's say that's the correct one, 5. Okay. So what's the probability that we're going to get the correct answer? Out of the 5 choices, only one of them is correct, right? Okay. Now it says if you eliminate one of the 5 possible choices and guess from the remaining choices, what's the probability that we're going to get the correct answer for part B? So it says we're going to eliminate one of them. That means we're getting rid of one. So now we only have 4 choices, one of which is correct. Okay. All right. I hope this is making sense, guys, as I'm going through it. I'm trying to be as clear as I can. Let's see. Veterinarian. In a given week, the veterinarian treated the following animals. Okay. Let's see. So the first thing we're going to do, guys, this is kind of like the rowboat problem. Let's see if we can find the total. All right. I'm going to grab my calculator right over here. Clear that out. Let's add them all up. 45 plus 40 plus 15 plus 5, 105. Okay, so here's our total. We got 105. All right, for part A, we're going to find the probability that the veterinarian is going to treat a dog. Well, out of the 105 animals that she treated, 45 of them were dogs. Okay, guys, I'm going to go ahead and divide them, say both by 5. I know 5 goes into 45 9 times. 5 goes into 105 21. We can divide them again by 3. So this is 3 over 7. Okay, there is a probability that it's going to be treated, that the next animal is going to be a dog. Okay, now let's do the next part. Suppose the probability is going to be getting a cat. Well, out of the 105, 40 of them were cats. So again, if we divide them both by 5, that's now going to give me 8 over 21. And then the last part, what's the probability that we're going to treat a rabbit? Okay. Out of the 105, 5 of them were rabbits. So again, if we divide them both by 5, that'll give us 1 over 21. Okay. All right, let's see what we got here. Okay, cell biology experiment. It says an experimental serum was injected into 500 guinea pigs. It says 150 of the guinea pigs had circular cells. So I'm going to do this. Circular cells. There were a total of 150 of them. Okay. Let's see. 250 had elliptical cells. So elliptical cells. There were 250. And irregular shaped cells, there was 100. Okay. Then it says, after the serum was injected, none of the guinea pigs that had circular cells were affected. So out of the 150, none of them were affected. Okay. 50 of them with the elliptical cells were affected, and all of those with the irregular shaped cells were affected, all 100. Okay. Now, let's see if we can answer the question. Determine the empirical probability that a guinea pig with A, circular cells, B, elliptical cells, and C, irregular cells will be injected by the serum. Okay, so for part A, the ones for the circular cells, well, look how many we had. We had a total of 150. None of them were affected, so the probability for that one is 0. Okay. Part B, the elliptical shaped cells. Out of the 250 that had elliptical shaped cells, 50 of them were affected. So let's reduce that, get rid of the 0, then we can divide them both by 5. That's 1/5. And then the ones for the irregular shaped cells, there were 100 of them, and all 100 were affected. So the probability that they're going to be affected will be 1. Okay. All right. Let's do another one dealing with deck of cards. So guys, remember the total number of cards is going to be 52, right? So the first part, what's the probability that we're going to get a 5? Again, if I come back over here, I have 4 5s, right? But guys, the easy way to do it is because we know we're going to end up having to reduce. We have 13 cards going across. How many of them are 5? One of them is. So 1 out of the 13. Okay. Okay, that's for part A. Part B, not a 5. Well, if 1 out of the 13 are 5s, how many are not? The other 12 out of the 13. Okay. Part C, a diamond. So let me come back here. How many are diamonds? These 13 out of the 52, or I can say diamonds are 1/4 because these things are set up into 4 rows. The diamonds is 1 out of those 4. So the probability that we're going to get a diamond is 1 out of the 4, right? Shine bright like a diamond. Yeah, I just went there. Let's see, part D. Okay. What's the probability that we're going to get a red card? Okay. Red card. How many of the cards are red? Half of them are red, right? Half of the cards are red. So red, 1/2. And part E, what's the probability we're going to get a face card? So let's come back over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So let's see. We have a total of 12 out of the 52. So part E, the probability that we're going to get a face card. Oops, face. There we go. Was 12 out of the 52. And I think we can say we can divide them both by, I think we did 4. So that's 3 out of 52 divided by 4. I already forgot. So let me turn this back on. 52 divided by 4 is 13. There we go. Okay. All righty. Let's take a look at the next one here. Okay, so it says, suppose the spinner is spun 1 time. Find the probability that we land on red, green, or yellow. So guys, I want you to think about this circle that we have here and notice that the circle is cut up into 3 pieces, but they're not exactly the same. So what we can do is we can say, look, let's draw this line here. Let's draw this line here. Now the circle is cut up into 4 pieces, right? So no, we have a total of 4. Okay. The red is going to be one of them. Yellow is going to be one of them. But the green is actually 2 of those pieces, right? Okay, so what's the probability that we're going to land on red? 1 out of the 4. On green, 2 out of the 4, which is the same thing as a half. And yellow would still be 1 out of the 4, right? Okay, I'm going to keep scrolling down over here. And let's see what we got. Let's see. So we have a little table. And we have vehicles here. We have General Motors. We have Toyota. We have the total. So, and then we have set them up as cars, trucks, SUVs, and their totals. Okay. All right, so we know that the total number of vehicles is 200. Okay, so for 59, it says, what's the probability that we're going to get a car? Okay. Well, out of the 200 vehicles, how many of them are cars? 85, right? So I know I can at least divide them both by, I know I can divide them at least both by 5. So 85 divided by 5 is 17. 200 divided by 5 should give me 40. So we'll have 17 out of 40. Okay. Let's do the next one. An SUV. Okay. An SUV. So 45 out of the 200. Let's do the same thing. Let's divide them both by 5. That's going to give me 9 over 40. Okay. All right. Let's go 51, not a car. Okay. So guys, just like we did before, if we already know that 17 out of 40 is going to give me a car, how many would not be a car? All I'm going to do is subtract. What's 40 minus 17? That's going to give me 23. Okay. All right, not an SUV. Okay. If I know that 9 out of the 40 are an SUV, then I have to know that 31 out of the 40 would not be an SUV, right? Okie dokie. Let's see. 63 says, a vehicle made by General Motors. Okay, so let's go like this. What's the probability that the vehicle we get is made by General Motors? Remember, there's a total of 200 vehicles. How many of them are made by General Motors? 123 of them, right? Okay, the next one says a vehicle made by Toyota. Okay. 200 vehicles total. How many of them are made by Toyota? 77. Okay. And then for 65, it says, what's the probability that it's a car made by GM? Okay. A car made by GM. So again, we still have a total of 200 vehicles. But if it's a car made by GM, there's only 55 of those, right? So guys, if we divide those by 5, that'll give me 11 over 40. Okay. And then for 66, it says, what's the probability that it's an SUV made by GM? Okay, again, we still have a total of 200 vehicles. SUV made by GM is going to be 28. Okay. We can divide them both by 4. So 4 goes into 28, 7. 4 goes into 250. So 7 over 50. Let's make sure that looks like a 5. Oops. Come back here. There we go. 50. Okay, so I think we got one more problem here out of 11.1. Here we go. Okay, so we got some national parks, it looks like, and their location. And it says that one of these parks in the list is selected at random. Determine the theoretical probability that the park, and it gives us some choices here. Okay, so let me see if I can just zoom out. Oops, didn't want to zoom out. There we go. Just so we can see it on here. Let's see, scroll down. There we go. Perfect. Okay. So let's come back here. Okay, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8. It looks like there's a total of 10 parks, okay? This one, what's the probability that it's located in California? So California, just looks like there's one of them. So 1 out of the 10. Okay. What's the probability that it's located in Wyoming? 2 out of the 10, which is the same thing as 1/5. Okay. What's the probability that it's not in California? Well, if it's 1 out of the 10, then this would be 9 out of the 10, right? And same thing out of here, if it's not in Wyoming, well, if 1 out of the 5 is located in Wyoming, then 4 out of the 5 would not be in Wyoming, right? And let's see, okay. And in Arizona, out of the 10, is it just 1? Yeah, just 1 is located in Arizona. So then that it's not in Arizona would be 9 out of the 10, okay? So guys, I want to make sure that that concept is making sense, right? And so again, look, if we know that one of them, if we know that one of them is in Arizona, aren't those other 9 not in Arizona, right? And that's how I'm kind of coming up with that concept, right? All right. So anyway, that was 11.1. I hope it made some sense.